Hello, this is Mr. Dada, and I will be doing the abbreviated version of our notes for today. So what I have here is a guide slide here that's going to walk you through the information that goes in your journal notes for today. To make things simple, whenever you see the yellow text, those are the entries that you need to make into your journals. So hopefully that makes sense. So it starts out by saying that a chemical bond is an electric force that holds atoms together in a molecule or a compound, right? So molecules, by definition, in case you don't remember, are just two or more atoms that exist with a chemical bond. So in other words, there's a bond that's kind of holding them together like that. A compound, practically the same thing, except with a compound, you have to have two different elements, two or more different elements combined together and then also bound like that. So this would be a molecule, and then this would be a compound. So molecules equal two or more of the same or different atoms that are bonded together. So you can have molecules that exist as either the same atom over and over, bonded together. So bonded there, bonded there, bonded there. Or it can be a series of different atoms, in which case that would also make it a compound. So you could have it as being a molecule and or a compound. So the picture here has done a good job of showing you the difference between an atom, a molecule, and a compound. So in this particular picture, this is an atom of helium. This is a molecule of hydrogen, which would be written like this. The H2. And then this would be a compound. What makes it different than a molecule is that it actually has two or more different elements. So you'll see here you have oxygen and you also have hydrogen. Now a compound equals two or more different atoms that are bonded together. So your examples would include H2O, which is a compound of hydrogen and oxygen, CO2, which is a combination of carbon and oxygen, and NaCl, sodium chloride, which is a combination of sodium and chlorine. So why do elements bond together? Well, ultimately, elements bond together because they're looking to kind of keep themselves stabilized. Those elements that are naturally stable are all of those elements in the 18th group, the noble gases. The reason they're stable is because if you look at all atoms in group 18, you will find that their outer shell is completely full. In most cases, that means they have 8 electrons in the outer ring, which means they're already stable by nature. But not all elements are like that. And so if they're not like that, well, then they will seek out chemical bonds with other elements that will allow them to fill out that outer shell. When atoms bond, they can share electrons, and the result is a full outer energy level. In this example here, what you have is you have two similar atoms of oxygen. So this is an atom of oxygen here, and this is just another atom of oxygen here. So one of the things you'll notice is that each atom by itself is chemically unstable. What that means is if you count the electrons, their valence electrons in the outer level, 4, 5, 6, you'll notice that that's not 8. And they need 8 to be happy or to be stable. So same thing over here, 1, 2, 3, 4, 5, 6, that's not 8. And so it's not stable on its own. So what ends up happening to make it stable is these two atoms will bond together, effectively sharing 2 of their electrons, so that way each atom can be stable. So now when you count the valence electrons, it looks like this. 1, 2, 3, 4, 5, 6, 7, 8. He is stable and happy. Over here, 1, 2, 3, 4, 5, 6, 7, 8, he is happy as well and stable. So these 4 electrons right here end up effectively being shared between these 2 atoms. And that's also how you end up with, instead of just O by itself, it becomes O2. For the rest of your notes, you will use these little shapes here and apply them wherever you think the correct answer is. So if you think it's a compound, you're going to put it here. If you think it's a molecule, you're going to put it there, right? So easy enough. And then on the next slide, you can just check your answers by uncovering these blocks here. Now keep in mind that some of these can be molecules and compounds. So you can end up effectively, the first one is a compound because it's 2 different elements, but it's also a molecule because it's at least more than 1 atom combined together. So see if you can get it completely right. For these last slides of notes, you have to use this slide. It says the properties of a compound are totally different from the elements that make up that compound. So for example, you have a colorless, odorless gas called CO2, which is called carbon dioxide, this right here. So carbon dioxide is made up of 2 different elements. Well, it's made up of carbon, which in its natural state is solid, and they almost look like little stones, like right here. And then you have oxygen, which in its natural state is a gas. Well, when you combine these 2 together at the atomic level to make the compound CO2, you end up with carbon dioxide, which is a gas that exists in our atmosphere. So in this case, you can tell that the property of being solid was lost when this compound was created. Similarly, if you look at salt, salt is a compound NaCl. So it's written like this, NaCl. When you combine these 2 elements together, they lose the properties of their elements. So for example, sodium by itself looks like this, whereas chlorine is a poisonous gas that if you inhale enough of it can actually kill you. But when you combine them together into NaCl, NaCl is basically salt. So when you combine them together, you get salt, but by themselves, the elements themselves don't look anything like salt, because salt looks nothing like a metal, and salt is definitely not poisonous in small quantities. So this is another example of how the properties of the element no longer exist when you combine them together in a compound. Now this doesn't happen all the time, but in some cases you do lose the properties or change the properties of the elements when you combine them into compounds.